Today we're going to talk about oval chucks. We're going to talk about a really old, very simple oval chuck, a Hall and Field oval chuck, and then a Linda White oval chuck. So let's take a look at this particular Swiss-made oval chuck now. This particular oval chuck is really nice in that it's so simplistic. This is a male and female dovetail with something called paddles on the side. The paddles are made of brass, and they also are bored on the ends to fit this cam ring, which is about 5 inches in diameter. There's a screw right here that pulls the whole cam ring off center when these two screws are loose. So it's actually mechanically very, very easy, and it works really well. So let's go take a look at the Hall and see the difference between the two. This is a Hall made in the late 1920s, maybe early 30s. And if you'll take a little closer look at this particular oval chuck, you'll notice how complex it is and actually maybe even a little over-engineered. So let's take a closer look. This particular chuck is three chucks in one. It's an oval chuck. Here's your cam ring back here, and it's actually pulling it off center on the end, similar to the other one, but it's pulling a whole cam ring and assembly in this direction. And it's very, very complicated. It's hard to put on with just two hands. And what's nice about it, though, is it came with a double eccentric chuck and a two-jaw chuck, which I don't use too often anymore. Now, the reason why the old-timers would have left this whole assembly on here, if you'll come around this other side, you'll notice that there's a pin right here, and it's called a zero alignment pin. It's a tapered pin, and when this pin fits into both of these sections, this cam is at a zero condition. It's not shifting left, it's not shifting right, which will allow a person to dial in their two-jaw chuck or their four-jaw chuck or their bezel chuck into zero by using your double eccentric chuck. So it's actually a really nice assembly, and once you have it zeroed in left to right, bringing it in this way is easy, and you could leave it there and do all your engine turning in one spot. But what we're talking about is the complexity of this particular chuck. It is very, very complex. It's also expensive, and it's a little over-engineered. Now let's take a look at the Linda White chuck that I've come up with and show you the difference between the two. If you'll notice that blue magic marker line on the bed, we'll shift it and you can see it. It's moving further away from the whole assembly, and right now it's almost a half an inch away. So it's nice and smooth, it's nice and quiet, and the cut we get on the part is super smooth. There's no striations at all, and it's just your basic exact idea that we had over there, and that was a male and female dovetail, a cam ring that I got from an old machine. The cam rings, by the way, have to be on true center in the up and down motion, and in left and right you just have to loosen these two screws and push it over, and the more you push it over, the bigger and longer the oval gets. The paddles are made out of brass, the cam rings made out of brass, and the rest are just, of course, Sure-Line parts. So it's just an execution in using Sure-Line parts to make other types of tooling. And David Lindo said down the road he's going to come out with an oval chuck. Now let's take a quick look at what's going on inside of this oval. You'll notice that there's a center line right here, and you'll always get that center line when your cutting frame is on true center. But if you want to make that look really nice, you drop your cutting frame below center, 1/8 of an inch, 1/4 of an inch, and that line turns into a beautiful S-curve. So you might want to play with the center line of the machine a little bit, and that'll go away and turn into something that looks even nicer. Well, that's all for the Rose Engine Shop today. We'll see you again some other time.